Myself, Srinivasan, working as a faculty in the Department of Mechanical Engineering at Seshanmore College of Engineering and Technology. And the last lecture we discussed was autoencoder. Autoencoder is basically it tries to learn the nonlinear transformation and it reduces the dimension of it. And now we are going to look at what are the different types of autoencoder. Okay, there are many types of autoencoder: only shallow and deep, convolution, and noisy, denoisy autoencoders. So there are many types of autoencoder. We'll look at a couple of types today. And shallow autoencoder, and as we know, this is when we use shallow means we will have very limited number of layers in the hidden. And the name itself, one can say it will have only one hidden layers. So if we use only one hidden layer, we can't learn the complex phenomena, and that is a disadvantage of several autoencoder. So as I said, it has only one hidden layer, and that is in between input and output, and it is used to learn the simple features of the data. Okay. So this is our X is our input and belongs to the, if it is a number of Rn is basically number of features. And this is a latent space of representation. Z is a latent space of representation. And which is going to be that less than M is going to be less than N. And when you reconstruct the X hat, and it is going to be same as the our input. Okay. So what is happening here in hidden layers, and we apply our activation function, and W is a weight and X plus B. Okay. So with the moment, this is basically for the representation, latent space representation. And here when we go for the construction and we use this activation function, and we get the input from the latent space, and similarly it works. Okay. So that is a usual way of representing shallow autoencoder. Okay. So as I said, this is simple hidden layer and simple architecture. It learns only basic features. It doesn't learn any complex features. Okay. So it has limited representations. So that is a disadvantage of shallow autoencoder. Next one is a deep autoencoder. Since it is a deep autoencoder, the difference between shallow autoencoder and deep autoencoder is that if you have multiple hidden layers, okay, this is a decoder part, this is encoder part, this is a decoder part. Here also you could see some multiple hidden layers between input and latent space representation or bottleneck. Okay. So it learns the nonlinear transformation. It try to capture this, captures the high level features, but starts from the low level to high, and it can represent better than the shallow because shallow uses only one hidden layer. Okay, so this can be represented in this way because the X is our input, and that will have many features when with high dimensions. Okay, so it represents the high dimensions. And in between, we'll have multiple hidden layers. And finally, in the lattice representation, we have this. The M is going to be less than that N. And similarly, when you go for decoded part, and we'll have many hidden layers. And the reconstructed one will be the same as the input one. So the difference between shallow and deep autoencoder is that, and in deep encoder, we have multiple hidden layers. So as we see, this is basically that is output of first hidden layer, and thus that goes into the second hidden layer. Okay, again similarly it will go here also. So this is basically our latent space representations. So this latent space representation is basically it will go into the decoder part. Okay, this is the encoder part, and this is basically decoded part. Okay, so this is basically decoded part. So since we use many hidden layers, we can able to understand, we can able to learn the complex phenomena. Okay, so this has many features, many applications. I can say dimensional reduction and denoising. Suppose if we give the noise image in the input and if we give you the output, it tries to learn the features and anomaly detection and everything. So this deep learning autoencoder can be used for simple table editor or red tasks. So if we, as long as we have a one-dimensional data, then it can be used. And that is the advantage of deep encoder when compared to shallow encoder. In convolution autoencoder, we will look at images that will have two-dimensional, that will have more. That is mostly for the images as well. So that we will see in the next lecture.